You've heard the theories, the debates, the discussions. Is Earth flat? Well, no. Earth is an oblate spheroid. However, there are planets that are flat, or rather more accurately, significantly flattened. Now, what exactly does it mean when we say Earth is an oblate spheroid? Well, imagine a sphere that you've gently squished from the top and bottom. It's still very much round, but it's slightly wider at the equator than it is from pole to pole. This is due to Earth's rotation, which causes the equatorial bulge. Our Earth, this oblate spheroid, measures about 40,075 kilometers around its equator. That's like running more than 1,000 marathons back to back. In terms of diameter, Earth is approximately 12,742 kilometers across. Again, that's a long way to travel, and certainly not a journey for the faint-hearted. But despite all this, despite the mountains, the valleys, the oceans, and the vast expanses of land, if you were to shrink Earth down to the size of a billiard ball, it would be smoother than the ball itself, that's right. Those towering mountains and deep ocean trenches, they're mere bumps and scratches on a cosmic scale. Now, having established that Earth isn't flat, let's shift our gaze to the stars, to the cosmos teeming with astronomical bodies. Among these numerous celestial entities, there exist planets far more flattened than Earth. We're talking about astronomical bodies that have been squished and stretched to such extremes that they resemble more of a pancake than a sphere. These so-called pancake planets are a fascinating subject, a testament to the diverse and often bizarre nature of our universe. They challenge our preconceived notions of what a planet should look like and remind us that the cosmos is a place of infinite possibilities. So, while Earth isn't flat, there are planets out there that are far more flattened than our home planet. Moving beyond Earth, let's delve into the universe's pancake planets. One such example, Haumea. Nestled within the intricate tapestry of our solar system lies this dwarf planet, one that stands out with its peculiar flattened shape. Haumea, named after the Hawaiian goddess of childbirth, is an intriguing celestial body that contrasts sharply with the spherical standard of most planets. Its dimensions are approximately 2,322 kilometers by 1,704 kilometers by a mere 1,138 kilometers. That's right, this celestial body is elongated like a cosmic rugby ball spinning in the vastness of space. Perhaps what's even more fascinating about Haumea is its rapid rotation. Picture this: while Earth takes a full 24 hours to complete one rotation, Haumea accomplishes the same feat in a brisk 3.9 hours. That's faster than you can watch most of the Lord of the Rings movies. This relentless spinning contributes significantly to Haumea's unique shape. Now, you might be wondering, how does this work? Well, imagine spinning a soft piece of clay at high speed. As it spins, the clay expands at the equator and flattens at the poles. The same principle applies to celestial bodies, a principle known in the world of astrophysics as hydrostatic equilibrium. In Haumea's case, its rapid rotation causes it to stretch along its equator, forming its distinctive oblong shape. But Haumea's flattened shape isn't its only claim to fame. This dwarf planet is also the parent body of a family of icy bodies in the outer solar system, hinting at a violent past involving a high-speed collision. It's an astronomical wonder, Haumea, spinning fast and holding its unique flattened shape. As we continue our journey through the cosmos, let's keep our eyes peeled for more of these pancake planets, celestial bodies that challenge our understanding of what a planet can look like. Now you may wonder, how do planets get so flat? Well, it all comes down to a simple yet powerful force of nature called centrifugal force. This is the same force you experience when you spin around with a bucket of water and the water doesn't fall out. It's also the reason why you feel pushed to the side when a car takes a sharp turn. Now imagine a planet spinning. As it rotates, the centrifugal force acts outward, pushing against gravity, which pulls inward. The two forces are in a constant tug of war, and this battle of forces has a profound effect on the shape of the planet. Let's take Earth as an example. Our planet is not a perfect sphere, but an oblate spheroid. This means it's slightly flattened at the poles and bulging at the equator. The force at Earth's equator is 0.3% less than at the poles due to its rotation. This might not seem like much, but when you're dealing with a planet, even tiny percentage differences can have a huge impact. Now, what would happen if Earth spun faster? The centrifugal force at the equator would increase, causing the planet to flatten even more. And if it spun slower, The centrifugal force would decrease and the planet would become more spherical. But it's not just the speed of rotation that affects a planet's shape. The planet's composition also plays a role. For instance, a rocky planet like Earth can withstand the forces of rotation better than a gas giant like Jupiter, which is more prone to flattening due to its gaseous composition. So you see, the shape of a planet is a delicate balance of several factors: the speed of rotation, the strength of gravity, and the planet's composition. So the faster a planet spins, the flatter it can become. It's a fascinating game of cosmic forces. Haumea isn't alone in its flatness. There are other celestial bodies with similar shapes. Some of these are so peculiar they might just spin your head right round. Let's delve into the cosmos and explore these otherworldly forms. First, we have Achernar, a blazing blue star that's not quite round. It's the 9th brightest star in our night sky, and it's found in the constellation Eridanus. This star is spinning so rapidly that its equatorial diameter is about 50% larger than its polar diameter. That's right, Achernar is an oblate spheroid, much like an M&M, but thousands of times larger and much, much hotter. Imagine a celestial body having an equator that's 1.5 times longer than its poles. It's quite the spectacle, isn't it? But we're not done yet. Let's journey further into the cosmos. Meet Cleopatra, an asteroid dwelling in the main asteroid belt between Mars and Jupiter. This celestial body has been compared to a dog bone or a dumbbell, but its unique shape is actually due to its rather swift rotation. In fact, Cleopatra spins around its axis every 5.5 hours. This rapid spinning causes material to move towards the asteroid's equator, resulting in its peculiar elongated shape. These are just a couple of examples of the universe's flat objects. There may be countless more waiting to be discovered. After all, the cosmos is a vast, unending expanse filled with mysteries waiting to be unraveled. So as we gaze up at the night sky, let's remember that not all celestial bodies are spherical. Some spin so fast they flatten out, becoming oblate spheroids like Achernar or elongated shapes like Cleopatra. These flat objects, whether they're stars, planets, or asteroids, add to the rich tapestry of our universe. From stars to asteroids, the universe is teeming with these intriguing, flattened shapes. So we've journeyed from Earth to Haumea, explored the science behind flat planets, and met a few others along the way. Let's take a quick galactic pit stop to recap our voyage. Earth, our home, with an equatorial diameter of about 12,742 kilometers, is an oblate spheroid. Then we ventured to Haumea, the pancake planet, elongated and spinning rapidly, with its longest axis nearly twice the length of its shortest. Don't forget the centrifugal force at play, working its magic to stretch these celestial bodies into their unique shapes, and there's more. The universe has a smorgasbord of other flat planets, each with their own fascinating characteristics.